And in this lesson in 6.6, you were learning how to solve right triangles. And so the idea of solving right triangles means determining or finding all the lengths and all the angles. So normally when you're given a right triangle, you're given 3 pieces of information. And so if we look at example 2, we only have 2 pieces here. We have this side and this angle. So what's missing? What should have been written down? Yeah, it's this, it's this right angle, right? This is a 90-degree angle, obviously, because we need at least one 90-degree angle. And so we have 1 piece of information, 2 pieces, 3 pieces. That means we're ready to start the question. First thing I like to do is to label the triangle. So as we read with our highlighters, it says solve triangle DEF, okay? Find the side lengths to the nearest tenth of a centimeter and angles to the nearest degree. So that tells us that we have the side lengths are 1 decimal place and the angles have no decimals. Let's label this triangle. We'll make the right angle angle D. This will be angle E, and this will be angle F. Let's make a plan. What do we need to find? Okay, well, I can see that I need angle F. Okay, what else do I need? There are 2 sides that are missing. What are those sides called? So let's take a moment to label the sides D, E, and F. Right, this is F because it's opposite from angle F. This here is E, and the hypotenuse is D. So now that we've labeled this triangle, we can add to our list of information that we must find. So in addition to angle F, we need to find the length of side F and the length of side D. Okay, and we can do it in that order. So starting off, we'll find angle F. And here, we're lucky that we have both angles, so we can just use the sum of angles. Right? That's a theorem that tells us that all angles in a triangle add up to 180 degrees. And so we can write like this. Angle F equals 180 degrees, subtract the other 2 angles. Subtract 90 degrees, subtract 43.5 degrees. Before you rush for your calculator, let's see if we can figure this out in our head. So 180 minus 90 leaves us with 90. 90 minus 43.5. Well, 90 minus 40 is going to be 50. But 90 minus 43 is 47. Good. And 90 minus 43.5 is 46.5 degrees. Is this answer exact or approximate? And you ask yourself, did we round to get this answer? Since we didn't round, it is an exact answer. So we leave the exact equal sign. Okay, great. So now I have this information. I'll write it in. 46.5 degrees. I'll change my color. Let's move on to finding side F. Now with side f, I see that I'm going to have to use one of the trigonometric ratios, sine, cosine, or tangent. And so let's take a quick pause to summarize the acronym that we learned yesterday. So, ka, toa. And that is so, ka, toa. This is not a formula, but this is what helps us select which trig ratio we're going to use. Okay, so in order to find side f, okay, let's write this down. Find f. We need to label the triangle. So let's label it using one of the angles. I'm going to use the angle that has been originally given. Okay, so I'll make angle E as the point of reference. And so based on angle E, what is the opposite, adjacent, and hypotenuse side? Okay, well, I know this is the hypotenuse. I know this side is opposite from angle E, and this side right next to it will be adjacent. Next, once we label the triangle, now we're going to circle the information we know and the information we need. So I've already circled this angle E. I also know the length of the opposite side. And I don't know, but I need to find the length of side F, which is the adjacent side. So if I am focusing on the opposite and the adjacent side, which one out of so, ka, and toa use the opposite and adjacent? Toa. Great. And so that means we're using the tangent formula. So I'll write tan of the angle. Which angle am I using? Is it E or F? Good. And tan of E equals opposite over adjacent. Now let's rewrite this formula with the numbers that we have. So tan of 43.5 degrees is opposite, which is 12 centimeters, over adjacent. I don't know the length of adjacent, but we're calling it F. And now let's use the T method to solve for F. So I'll make both sides into a fraction. And I'll go 1 times 12 divided by tan 43.5. So watch this. F equals 12 over tan 43.5. Is it okay that I just wrote 12? Yeah, because it would have been 1 times 12 in the numerator, and that's just 12. All right, so everyone's grabbing their calculator. Okay, if you don't have your calculator yet, please take it out of your bags. Make sure you're in the degree mode. Okay, if you don't have a calculator, see if the supply teacher can pause the video and find the calculators, the extra calculators in the desk. Okay, so we're going 12 divided by tan 43.5. And I get a lot of decimals. So let's scroll up to check how many decimals we were asked to give. Side lengths to the nearest tenth of a centimeter. Okay, so that means 1 decimal. So I've got 12.6 centimeter. Now, since I rounded, what type of equal sign am I using? Great. The approximate equal sign. Good. Okay, moving on to step 3, and that is to solve for side D, which is the hypotenuse. So we'll say find D. Now, since I'm finding D, I'm going to take away my circles. I'm going to keep angle E circled because I'll keep the labels, right? I can keep the opposite adjacent hypotenuse if I'm still using the same angle. Okay, so now let's circle what we need to find. I need to find D. And then I have a question. What other piece of information do I know? Because I know the length of the opposite side, I also now know the length of the adjacent side. We just solved for it. Which one of these two values? 12 centimeters or 12.6? Which one is more accurate? And that would mean which one was not rounded. Yeah, so the one that is more rounded is the one that has not been rounded, the one that is exact is 12 centimeters. So let's use that because that will ensure that our value of D is as close to its true value as possible. Okay, so what did I just circled? I circled opposite and hypotenuse. Go back to SOHCAHTOA, and which one uses opposite and hypotenuse? Why, of course, so, which is sine. So let's write out the entire formula. Sine of E equals opposite over hypotenuse. Right? So on the quiz, I do want you to write the entire formula before you add any numbers. Okay, this is just really, it's good math communication. And now we'll write this again with our values. Equals, my opposite is 12, and the hypotenuse I don't know, but I'll call it D. Let's use the T method to solve. So we'll go once again, 1 times 12 divided by sine. So I get D equals 12 over sine 43.5. You see, it's very similar to what we used to find F. The only difference is the ratio we used. And that's what will determine the different value. So let's see what we get when we punch this into our calculators. Right, once again, folks, make sure you're using your calculators. The more active you are in this learning process, the more you will learn. Okay, and I got an answer of, oh, maybe I'll move that over. That D equals approximately 17.4 centimeters. Before I move on to the next question, let's use our critical thinking to see if this actually makes sense. So, does it make sense, first of all, that D is 17.4, right? Does it make sense that this side is the longest side? Right, it does because the hypotenuse is always the longest side. Okay, great. check mark, right? So we did a critical thinking check there, and that makes sense. Now, a little trickier is the critical thinking check for side F. So what we're saying is we've got a triangle that has two angles that are very similar, 43.5 and 46.5. It's almost an isosceles triangle, right? This picture here is not accurate. A triangle that is 43.5 and 46.5, I don't know, might look like that, right? And so where the sides, these angles are almost identical, and as a result, these two sides are going to be very close in length, right? We'll have 12 and 12.6. So again, yeah, that does make sense for me. Okay, so that's how I can use critical thinking to check if I'm on the right track. Okay, so there I go. So I have my 3 pieces of information. If you want to, you can make a list. You can either keep them in boxes or you can make a therefore statement. Angle F, 46.5 degrees. Side F, approximately 12.6 centimeters. Side D, approximately 17.4 centimeters. And that goes in a box. Beautiful. And although my solution sort of goes all over the page, it's organized because I'm numbering step 1, step 2, step 3. Right? Sometimes we don't have space to do a completely vertical solution, but if we keep it organized, then that's sufficient. All right. So this is what it means to solve a right triangle. And so you'll do a bunch of these questions for homework. And if you finish all the questions that I assigned, then select more questions to work on, because you will have a question like this on the test. Sorry, on the quiz on Friday. Almost exactly like this, where you're finding all the angles and all the sides. Let's move to page 13. It's a word problem, so I'm definitely taking out my highlighter and doing some active reading. Yeah, so take out your highlighters, and if you don't have a highlighter, use a pencil to underline the important pieces and circle what you're being asked for. A lighthouse sits at sea level in the water. What that means is this is where the water is, right? And so the bottom of the lighthouse is at the same level as the sea. The angle of depression, what is that? To sight a small fishing boat at sea is 27 degrees. So what is important here is to say that the angle of depression is 27 degrees. How far from the base of the lighthouse is the fishing boat? So how far is the fishing boat to the nearest meter? So can everyone take 30 seconds to read that question again and to look at the picture and see what you understand from it? So I'm introducing this idea of an angle of depression, and in addition to that, there's an angle of elevation. So what I want you to do, folks, is put your hands in front of you, like stick your hands out horizontally as if you're a mummy and you're walking and both of your hands are just in front of you. Okay, now take one hand and make an angle of elevation, right? So you're raising that hand. And so the angle of elevation is between your horizontal hand. So watch here. This is the horizontal. And then my other arm did this. Zoop. Okay, it went up. So this is an angle of elevation. And it always goes from the horizontal, from a horizontal line. The opposite of the angle of elevation, now if we have our one hand out like that, another hand out like that, and then I say use one arm to make an angle of depression. Zoop. And so this is our angle of depression. Right? So depression alludes to going down and elevation is going up. In both of these cases, the reference point is always a horizontal line. Now, this idea, folks, is a little bit complicated. It won't be included on the quiz, but it can be on the test, and I'll spend some more time with the idea of the angle of elevation and depression. Now that we understand what this angle of depression is, let's see how it works for this question. So what it's saying is the angle of depression towards or to sight, to see a small fishing boat is 27 degrees. So that means someone is inside this lighthouse, right in this window. Okay, this green dot. And they are looking and they see, oh, there's a fishing boat. Right here, there's a fishing boat. And so the line of sight, meaning the line that goes from the eye of the viewer towards the boat, makes this angle. And if we measure the angle from the horizontal, just a random horizontal line, the angle that is created is 27 degrees. So this angle here is the angle of depression. Okay, please note, it is not this angle. That's a very common mistake. Someone will say, oh, but I want the angle to be inside this triangle, right? They'll say, it needs to be inside the triangle because this is my triangle. So this must be 27, but it's not because the angle of depression always goes from a horizontal line. Okay? However, we can use our parallel line theorems to bring this angle into this triangle, right? So the triangle we're looking at is A, B, and C. And so the line of the water is horizontal, as is this horizontal line. So we can say they are parallel. And with those arrows, we're showing that they're parallel. And then based on the PLTZ, so parallel line theorem with the Z, if I draw a Z, the two angles on the inside of the Z are identical. That's how we bring in that 27. So that means that this smaller angle here is the 27. And folks, look at this. From the water, what would you call this angle? If the water is the horizontal, what is this angle called? Good, it's the angle of elevation. So with this parallel line theorem, we see, oh, the angle of depression and elevation are the same. Okay, so now I know one of the angles in the triangle. I also know one more angle, and that is the angle that the lighthouse makes with the water. We can assume that the lighthouse is perfectly vertical and that the water level is perfectly horizontal. And that gives us a right angle. Okay, so now we have two angles and we need one more piece of information. And so what we see is that we need one more piece of information. So let's give this lighthouse, right? We don't have enough information, so I'm going to make something up. I'm going to say that the lighthouse is 15 meters tall. Right? We're going to say, okay, we need a length. So let's make the lighthouse 15 meters tall. And so now I have three pieces of information: angle, angle, side. Okay, before I solve, let's redraw this triangle. There's a lot going on in that picture. So let's redraw it. Only triangle ABC. So I know this is a right angle, angle B. C, I don't know. A, I know it's 27 degrees. And side A is 15 meters. Now let's read the question to see what we're being asked to find. What we are asked to find. How far from the base of the lighthouse, how far is the fishing boat? So I'm being asked for this distance. And on this triangle, that's what I need to find. I need to find the distance between vertices A and B. Okay. So now that we've broken it down to a simple right triangle, can we find that distance? Absolutely. So let's see, what do we have? We have this angle A. Let's label the triangle based on angle A. So label the opposite, adjacent, and hypotenuse. Circle the information you're given, or the information we have, and circle what we need to find. So since we've circled adjacent and opposite, which one out of SOHCAHTOA is it? It's TOA. Okay, so let's start the solution. Let's write out the equation. Tangent of angle A equals opposite over adjacent. Let's substitute in the values. Tangent of 27 equals 15 over, instead of adjacent, I'll call it lowercase c, side C. Okay, I'll use the T method. And I get 1 times 15 divided by tan 27. So C equals 15 divided by tan of 27 degrees. And we're being told to round to the nearest meter. So that means no decimal places. And so I get an approximate value of 29 meters, right? 29.4, but we round it down to a 29. And because this is a word problem, I need to write a statement. Therefore, the boat is, let's say, approx 29 meters away from the lighthouse. And let's pause and look to see if, let's do a critical thinking check. So, does 29 meters make sense? Sure, it's similar to 15, right? It's not 200 meters. If I had 200 meters or 0.2 meters, I would know I made a mistake. So this is similar enough. Makes sense. Great. All right, so folks, finish up the homework from yesterday. Give yourself a few more questions. If you're not sure which ones to try, you can look at this suggested homework here and do those questions. And then for those of you who are still stuck on SOHCAHTOA, then please come to extra help tomorrow at lunch so that we can work on that. We can continue working on it. All right, I'll see everyone tomorrow. Bye-bye.